Hello everyone. In this video we'll discuss what is a polynomial and terms related to polynomials. Before defining polynomials, let's understand the following words. Constant. A quantity that never changes is known as constant. For example, all numerical values are known as constants. Example, 2 minus 5 by 2, root 3, even pi is also a constant. Next is a variable. Quantity whose value changes with the situation is known as a variable. Generally, variables are represented with alphabets like X, Y, Z, P, Q, A, B, etc. Next is term. For example, 2x plus 3y plus 4z. If you observe here, the different words are associated by arithmetic operation addition. So here these words are nothing but terms. So here 2x is a term, 3y is a term and 4z is a term, right? Let us define some more terms related to polynomials. Coefficient. So let's take one example. 3x square. If you observe here, the variable x square is multiplied with a number 3. So this 3 is called coefficient. That is, the number by which a variable is multiplied is known as coefficient. If I write one more example over here, x square plus x minus 1. So in this particular case, what is the coefficient of x? It's nothing but 1. If a number is not mentioned, then we can say that the coefficient will be 1. If I take one more example, minus 2x plus 3y. So in this case, the coefficient of x is minus 2. Similarly, coefficient of y is 3. Right, students? The next term is degree. The degree is nothing but highest exponent of a variable. Let's take one example, 2x square plus 3x minus 5. If you observe here, the exponent, that is power of the variable x, is 2 and this is highest. So the degree of this expression is 2. If I take one more example, 4x cube minus 3x plus 4. In this case, degree of the expression is 3, as the degree of the power of the variable highest power is 3, right? Next is algebraic expression. It's nothing but it is a combination of constants, variables associated with arithmetic operations. Let's take one example. 2x square plus 3x plus 5y minus 7. This is called an algebraic expression as we have constants, variables, and these are associated with arithmetic operations. Students, now let us define polynomial. The word poly means many and nomial means terms. So that means it is a combination of many terms. So let's define polynomials. It's nothing but it's an algebraic expression with whole numbers as exponents of the variable. Let's consider one example, 2x cube plus 3x square plus 5. If you observe here, the exponent of the variable is a whole number. Then we can say that it is a polynomial. Generally, polynomials are represented as p of x or h of x or g of x. That indicates that the expression is in terms of variable x. Such examples are known as polynomials in one variable. We can write even polynomials in 2 variables or in 3 variables as well. So, when I say that it's a polynomial, the exponent of the variable should be a whole number. Let's take one example, 2 by x plus 3. Can we say that it is a polynomial? No. Why? Because if we represent this in terms of exponent, it is going to be 2 into x to the power of minus 1 plus 3. That means the exponent of the variable x is minus 1. As you know that minus 1 is not a whole number, so I can say that this is not a polynomial. Right, students? Let's consider one more example. If it is 2 root x plus 3. Is it an example for a polynomial? No. Why? Here x to the power is 1 by 2, right? 2 into x to the power of 1 by 2 plus 3. Even 1 by 2 is also not a whole number. So, I can say that this is not a polynomial. Right, students? If it is given as 5. Even this also I can say it as a polynomial, as 5 can be represented as 5 into x to the power of 0, where 0 is a whole number. So we can consider this is an example for polynomial. Now let's see different types of polynomials. Based on number of terms, polynomials are categorized as follows. Monomial. Polynomial with a single term is called monomial. Example, 3x, 2x square, 5, minus 3, etc. So if you observe here, we have only a single term. Such type of polynomials are known as monomials. The second one is binomial. That is a polynomial with two terms. For example, 2x square plus 3x, 5x minus 3, 3x cube plus 4x, etc. Third one is trinomial. The word itself indicates that where we will have three terms, 2x square plus 3x minus 3. Or we can write it as one more example as 5x cube plus 3x square plus 7, etc. So based on the number of terms, polynomials can be monomial, binomial and trinomial. Now let's categorize polynomials based on the degree of the variable. Students, now let's define polynomials based on the degree of the variable. The first one is called a linear polynomial. If the variable exponent is 1, such type of polynomials are known as linear polynomials. For example, 5x plus 8. If you observe here, the variable x power is 1. So, such type of polynomials are known as linear polynomials. So, the general representation of a linear polynomial, that is p of x, is represented as ax plus b, which is in terms of x. If I would like to represent in y, then it will be p of y will be equals to ay plus b. So, some more examples for linear polynomials are 3y, or even it can be in the form of 2x, or it can be in the form of 3z. So from these examples we can say that linear polynomial will have at most two terms if it is represented in terms of one variable. Now let's look into second type of polynomials called quadratic polynomial. Quadratic, the word quadratic indicates that the power of the variable is 2. So example is 2x square plus 3x. This is an example for quadratic polynomial. So the general representation of quadratic polynomial is ax square plus bx plus c. If you observe here, we have three terms. That means a quadratic polynomial will have at most 3 terms, or we can have less than 3 terms also. The word cubic means the degree of the variable is 3. So a polynomial of degree 3 is called a cubic polynomial. So one example for cubic polynomial, p of x is equals to 3x cube plus 4x square minus 3x minus 7. So if you observe here, the power of the variable x is 3. So it's a cubic polynomial. So the general representation of a cubic polynomial is ax cube plus bx square plus cx plus d. So from this we can say that a cubic polynomial will have at most 4 terms. Till now we have discussed polynomials in terms of one variable. We can also define polynomials in 2 variables and polynomials in 3 variables. Let's write one example for polynomials in 2 variables, which will be represented as x square plus xy plus y square. If you observe here, we have 2 variables, right students? Similarly, we can represent a polynomials in 3 variables as 2x square plus 4y plus 3z. If you observe here, we have 3 variables, right? From above definitions, we can write a generalized form of a polynomial of degree n as f of x is equals to a n x to the power of n plus a n minus 1 x to the power of n minus 1 plus a n minus 2 x to the power of n minus 2 and so on a1 x plus a naught. If you observe here, this is a polynomial of variable x. Here an minus 1, an minus 2 and so on a1 comma a naught are known as coefficients, right? These are coefficients of the variable x. And here an is called leading coefficient. That means it is the coefficient of highest degree of the variable, and a naught is known as constant. Students, whenever we learn a new topic, the very first question comes in our mind is, what are the applications? Why to read this and where we will use this, right? So the applications of polynomials are, it is useful to represent and to interpret, forecast, market trends. It is also useful to represent cost curves. In physics, to find out displacement of an object, we use polynomials. In meteorology, to represent weather patterns. And even in roller coaster rides, to represent the rides, we use polynomials. In this way, polynomials are useful in our day-to-day life, knowingly or unknowingly. In next session, we'll discuss zeros of a polynomial. Please feel free to provide your questions or comments in comment section. Thank you for listening and have a great day.